Well, good morning. It's Richard Sealine with the Resilience Innovation Hub and Roar Partners. I'm honored to have Rahul Shah with ChemSearchFE join us this morning. This is an opportunity for us to get acquainted with some of the work that is underway around future-proofing America and how ultimately we can change the nature of resilience from various disasters, as well as the opportunity for uninterruptible supplies of water into the commercial and industrial space. What we're looking forward to this morning is this opportunity to hear from Rahul about where we are headed in regards to new technologies and new solutions. As a result of the work that Rahul's been doing across the country, we think there is a unique moment to capture all of water from a reuse approach. Rahul, thank you. And let me just share a couple of things that will set the stage for us. And of course, folks who are watching this can read faster than I can speak. But as you know, we've been listening to real estate developers, building owners and managers, all the way over to insurance, reinsurance, and financing about this need to make a pivot. And I think one of the realities that you've shared with me is the notion that if we can embed solutions like what you're going to present in a few minutes, we can actually change the bottom line. We can change for building owners, asset owners, and investors the returns on investment, but also to secure from a business continuity the operations of these various types of buildings. So our objective is really trying to identify, embed, and deploy best technologies, equipment, and data tools, whether it's under a retrofit or new construction. And that's the reason why we felt that starting a new series with Rahul and the work that ChemSearchFE has underway would be a significant start, because as you can see and read on his bio here, this is not just a startup company. This is a 104-year-old company. So I want to start with a big one or two questions, Rahul, and then really turn this over to you to share the solution that you've already deployed. So this isn't some, thing that's sitting, in the lab. It's out there already. You've been going all across the country. You've been on more panels and conferences just alone this year. Tell me, what are the big issues in buildings, real estate, and water right now? What are those big challenges that you're hearing people talk about?
Yeah, well, thanks for having me on, Richard. It's always a pleasure. Happy to be part of this conversation. The big questions are interesting. There's lots of conversations going on, in commercial, multifamily, healthcare, facility management in general, around resilience and sustainability. But what I have noticed significantly is that the conversation is pivoting. While energy remains a big part of what of the I guess footprint of a building, energy and waste. But the reality is, energy is not a natural resource, and we're not running out of it. Whether we go with clean sources like wind or solar, or fossil-based sources like coal, or even nuclear, we're not running out of it. We can make more. It's a renewable, I guess, resource that's available. It's man-made, but water is not. It's not something we can manufacture out of thin air. There is a limited supply of it if you don't take desalination, and that has its own implications. So it's interesting when I started this journey, and you're right, ChemSearchFE has been around for 104 years. We do over $1 billion worldwide in 55 countries. And we have my particular division has specialization in facility management. So we understand, how buildings in commercial property management or large multifamily or healthcare or education or hospitality, we understand what those operators are looking for. And there are a couple of key points that you mentioned on this, is that, yes, doing the right thing in sustainability has its own benefits, but at the end of the day, these are for-profit organizations. So you have to make whatever you do from a resilience perspective to also be financially viable for the asset owner. So that's really where we have specialty in finding ways to help buildings augment their water requirements, which in commercial buildings and large facilities, commercial, institutional, that's really where the bulk of the water is being used. To make an impact on water on a per home basis is not necessarily the impact that you want. But an average American home uses 110,000 gallons of water a year, but an average building that's over 500,000 square feet uses 8 million gallons a year. So
wow.
Where do you want to focus? You want to focus on that user where a lot of the water is non-potable, whereas in a home the bulk of the use is potable water, and potable has its own implications because it's for human consumption. But I don't think that a lot of the asset owners or a lot of the building operators certainly know, but the building operators do what the asset owners tell them to do. But I don't think the asset owners really understand the volume of water that goes towards a building that is of significant size on what it takes to keep it operational. So that's where we found an opportunity.
All right, let me unpack 2 or 3 things and then really get into what I'm excited about and why I've been excited to make sure that folks in our networks and strategic partners understand what you've been working on. Let me unpack a couple things. You really hit the nail on the head, and that is we appreciate and recognize the relevance of LEED and LEED certification, but that really is no longer sufficient in certain places where you're running out of water or the quality of water has changed. The other part that you're also, let me see if I raise one other and just make sure I'm headed in the right direction. The other part of this is that water and water treatment have a significant demand on energy. So if you're really looking at water and water efficiency within the building, in the envelope, so to speak, of the building, you're potentially solving 2 problems. One is recapturing, reusing water that's precious in a lot of drought or limited quality types of in quantity scenarios. But if done right, you're also reducing the power demand. Am I saying that correct, Rahul?
Possibly. Any kind of reclaimed water system has an energy demand, but the benefits from the reclamation of the water far outweigh what that energy demand is. Right. So you mentioned 2 things. Number one is LEED, right? So look, the United States Green Building Council does a great job of making sure that they set the standards of what it takes to run a sustainable and resilient building and reduce a building's carbon footprint. They just came out with their new LEED version 5, scenario or certification process. And I'm disappointed that they didn't make water a more key part of what they're talking about. And politically as well, the conversation has been going on so long about energy and fossil fuels and global warming and all this stuff that's out there without people really understanding a lot of what's going on. I'm not saying any of that's right or wrong. I don't have expertise in those areas, but clearly from what we see, just from even just the normal news across the world, water is not infinite. And currently in the facilities management world, water is still the cheapest, best, safest media to perform several functions in a building. And that technology has not evolved to a point where where any other technology is more efficient or better or more cost effective to be able to cool a large building, a 2 million square foot building, to heat or cool it.
But this is right. But this is where I think what you're going to share with us does get impressive. It has multiple benefits in multiple ways, but I think what y'all have done a great job is really showing the cost benefit. There's offset, there's revenue generation. I mean, you can describe this better, and I'm going to turn the screen over to you to share some of the background on how y'all have been approaching it, because you've got 3 or 4 use cases, all very unique geographies, different types of buildings. But what our objective has always been in partnering with y'all and looking at this is that there are multiple cost benefits. Some of them are offsets, some of them are revenue generation, some of them are both, which to me should signal to business owners or to asset owners, not just the managers and the operators, but the asset owners that are looking at ways to squeeze more, revenue, or in some way reduce costs, which ultimately should change the balance sheet. That to me is what you've really demonstrated. Is I may not need to know all of the technical aspects, but from somebody who's a COO or CFO who's looking at the entire building and the operations of the building, I think what you've recognized is we've got the technical solution and we know how to deliver it. But what we do also know is, as it says here, resource management. So let me turn the screen over to you and let you jump into the details of what you all have been working on.
Yeah. So to begin with, you're right. What we've done is we've been able to make sure that we can anything that we do, we're going to do our best to make sure that we have the ability to. Oops, I think I did something wrong here. Forgive me. That we have the ability to provide a financial ROI. Most of our systems, which are out there, have a ROI of less than 4 years. So 25% ROI is our target on any reclaimed water system that we sell. I thought I'd start off by just kind of showing people where in a large commercial or institutional building where the water is used. This is EPA data, comes off of their WaterSense website. And you'll notice that in a large commercial building, 28% of the water is used towards heating or cooling. So water is the safest, cheapest media to be able to either reject heat or cold from a building. 13% of the water is used for kitchen dishwashing, which is potable. Another 22% average across the country is used for irrigation. And then 32% is just sanitary waste, which is human consumption. So out of this, in this matrix, you can see 50% of the water is used for non-potable applications. And that's where we've decided to focus. Because if we can make an impact on the non-potable applications, it's a lower risk profile, not just from our perspective, but also from the building owner's perspective, to not mess with human drinking water or any water that comes into contact with human beings. So that's where we've decided to focus. And it's also interesting, our focus currently has been on existing buildings. On new buildings, there are several technologies available. Gray water, for example, is the prevalent technology to be able to capture lightly used water, like laundry, sinks, showers. Anything that's not black water can be reclaimed and reused for non-potable applications like toilet flushing, or cooling tower makeup, or irrigation, utility washes that can be done in a new building. But what I want to focus on today is existing buildings. And there's this, it all started off with rainwater harvesting. So let's just be honest, okay? In the areas where there is a paucity of water, if you particularly in the United States. The further out west you go, the harder it becomes to the rainfall index just isn't there. And even in areas where there is good rainfall, like for example in Florida or other parts of the country, the city infrastructure is aging, and they don't have the catchment systems that can capture that water, store it, clean it up, and then meet the continuously growing demand for water, right? So rainwater is really hard to do. If you have an existing building, even with a large flat roof, that water exits the building in multiple different places. So how do you bring it together to a central place? That's hard to do. You have to rip the building apart. And then you have to catch the water when it rains. It doesn't rain out 24/7, 365. So you need a 500,000 gallon cistern. That's hard to do, to find the space, the mechanical space to store those systems. So rainwater just doesn't have really any good ROI, in our opinion. So I mentioned gray water. In new construction, yes, 100%. But in an existing building, the gray and the black water is plumbed to exit the building using the same wastewater infrastructure. So if you want to separate the sinks and the showers and the kitchens and the laundries from the toilets and the urinals, you would have to rip the building apart. And there's just no ROI in doing that. So we found two sources of water in a building where we don't have to do that. And yes, we have the use cases available. So what we've discovered is that there is a vast amount of shallow groundwater in the United States. So if you go to the Midwest, if you go to Los Angeles, if you go to Las Vegas, Dallas, Florida, Atlanta, a lot of major metropolitan areas that have these high-rise buildings that use huge amounts of water. And let me put the use to you in perspective. So at your home, you would have a 1-ton, 2-ton, 5-ton system that would cool your home. A commercial building, commercial or institutional building, has 1,000-ton, 2,000-ton, 5,000-ton cooling system to meet the demands of cooling that particular building of that size. That is especially one that's occupied, because human beings are just 98-degree heat pumps, essentially generating heat. And the more humans you have in a building, the harder it becomes to cool the building. So if you have a 1,000-ton cooling tower that operates at 100% load, 365 days a year, which in many parts of the country it does, you would use 8 million gallons of fresh potable water to cool that building. That's a lot of water. So what we found is there's an opportunity with the shallow groundwater, because buildings engage. If you have a 60-story building, 40-story building, 20-story building, generally speaking, in order for that building to stand upright, you have to go into the bedrock to set the foundation. And when you go into the bedrock, you engage in a process. You often run into a water table, and you engage in a process called dewatering, which is essentially they eject the water from the construction site. So it prevents something called sloughing that makes the soil stable during the construction process. And then that dewatering well, which is just a well with a pump in it, becomes part of the infrastructure. And then through the course of the life cycle of that building, that water is just ejected, and it's in shocking numbers, right? So it's fresh groundwater. It's not reclaimed. It's just shallow groundwater that is being ejected and lost. So we found an opportunity in that. We have 3 use cases that are available, and we use the water primarily for cooling tower makeup. So here's an interesting case study. This is at a hospital in Ohio. It's an 800-bed hospital. It is in Dayton, Ohio. They have a 5,200-ton evaporative cooling system that under normal conditions will use 17 million gallons of water per year from the city to cool the building. So 17 million gallons is the equivalent of 150 community homes. So that's the impact that we're trying to make. So we put in, this is a picture of the dewatering sump, and we put in our groundwater system in there, our groundwater harvesting system in there. This system is designed to operate at 43,000 GPD per day. It's a mixture of low pressure RO, pre-filtration, and then some custom blending to make sure that the water quality we deliver to the cooling tower is the same, if not better, than what the city sends them. And in the last year, we saved this building 7 million gallons of water. And in the first year, even though this particular slide says that we had projected a $90,000 cost savings, but in the first year we saved them over $141,000.
Wow.
If you
Wow.
look at the ROI, the total burn on the system, including the installation, was about $400,000. That's under 4 years. So really good ROI, and the impact, no detrimental impact on the cooling tower because of the quality of the water that we're sending. And then just the pressure that the hospital was putting on the city to be able to give them this much water is released. So the city can take their water and meet more demands that the public has, because this particular facility had the foresight to do something innovative and put this. And this system's now been in operation for 2 years, so it's fully operational.
Rahul, let me make a quick observation. First off, a hospital system is considered critical infrastructure.
Yeah, that's the other part. So
right.
this hospital had come close to experiencing a force majeure event where they had a storm, and their city, the main city makeup line, runs under a creek, and they almost lost pressure. So if they had lost pressure, there go the ORs, the ERs, the data centers, everything that requires critical conditioning, because the air handling system would have gone down. So now, in the event that, God forbid, that happens again, at least the building has the capability of making sure that those critical areas that require critical patient care, data management, which deals a lot with security, data security as well, that those areas are conditioned and continue to remain operational until the city is able to restore the power. Does that answer your question, Richard?
And that's spot on, because one, because of its critical infrastructure nature. Two, because of its business continuity, like any institution or building must maintain. But the third part is, like you raised, and that is that the hospital system, through y'all's application here, is actually providing a reserve amount of water back to the citizens, which becomes a shared benefit of everybody. So
Yeah,
keep on going.
I mean, I wouldn't say what occurs is that the city doesn't have to give of the 17 million gallons that Kettering needed, or this hospital in Ohio needed to run the evaporative cooling system. The city now only had to provide them with 10 million, because we were able to manufacture or give them 7 million gallons of in-building water, right? This is another use case. This was the first one that we put out there. This is at the Bank of America Plaza in downtown LA. Another, this one's 55 stories, 5,000 tons worth of cooling. This was the first system. They have a dewatering sump in there. And this dewatering sump can capture, it's a big 60-foot sump, and this system is designed to operate at 10,000 GPD, saves 3.65 million gallons of water a year for cooling tower makeup. And then our most recent system is in Illinois. This is in Schaumburg, Illinois. This is for Zurich American Insurance. It's their world headquarters. And this system is designed to operate at 25,000 gallons per day for cooling tower makeup. They have a dewatering sump as well. So we're going to save them 5 million gallons of water. That system also now is fully operational and is running at about, right now, because it's still not peak cooling season in Chicago. In Chicagoland, rather, is saving about 10,000 GPD. But as the temperature ramps up, that water demand is going to go up, and the system is rated to meet those requirements. So this is two-stage filtration. We do an ion exchange because the water was really mineral dense. So we apply a resin bed to get rid of the calcium and the magnesium, and then we further purify the water using an 8-membrane RO system, and then it goes into a holding tank. And it's a fully automated system tied into the building automation. So when the cooling tower says, hey, I need water, if the system is making water, it will first take water from the system. And then if the system is not able to meet the demand, then it will switch the valve over and start pulling from city. So we've got 2 other projects in the works. There's a system that's about to go into a pretty prominent building in downtown Houston. And then also at a very large university in Ohio, which has a shocking amount of groundwater. And then we're also working with a couple of really large casinos in Las Vegas, where these buildings have 50 million gallons of shallow groundwater that's basically just being lost to the storm sewer system. And once the water goes into the storm sewer system, it doesn't go to the city anymore. It just gets lost into whatever area that storm sewer system enters into the ocean. If you're close to to the shore or into the desert if you're, or back into an aquifer, but it's really hard to see where that water goes. So that's our current use cases. The other use case for existing buildings is a source that is called cooling coil condensate recovery. So if you have a building with a 500-ton cooling load, you can generate 1.2 million gallons of water per year. I mean, this is pretty simple. The way you get rain is you have heat, water evaporates, starts to rise, comes into cooler contact with cooler temperatures as it rises. It then turns into water vapor, condenses, and you get rain. Same thing goes on in a building's air handling system, where you have really hot air that is blown over a really cold coil to be able to reject the heat and send cold air back into the building, but that creates condensation. And this is a really pure form of water. It is free of ions, so it's almost better than DI quality water. So when that water is sent to a cooling tower, generally speaking, you get just a much better cycle experience, and that water goes even further. Rice University, for example, in Houston, captures out of their air handling units 15 gallons per minute, between 12 to 14 million gallons of water saved per year out of a variety of different air handlers. We're working with the Crypto.com Center in downtown LA, and this is a shocking number. They've got a 4,000-ton cooling system. Out of their 5 or 6 main air handling units, they get 5 million gallons of water a year that currently is going down the drain, and it's pure water. So these are the two primary sources of water that can be used in an existing building to capture and reclaim some water without having to rip the building apart.
Wow. And I mean that seriously, because what you just walked through is 3 different types of buildings, 3 different types of geographies, 3 different types of demands. So you know what I keep on coming back to is this idea of resilience. How do you help a building, a campus, a community to remain resilient against any number of types of threats and disasters, but also how do you create an uninterruptible supply of water? You know, I think you just said that you and I talked about this, you know, early on, that Ed Archuleta, the former CEO of the El Paso water system, became known across the country by saying that the best water you got is the water you got.
Yeah, and there's a dual impact here, Richard. So, you know, currently the way it works is most city water utilities have what's called a closed circuit system, right? So every drop of water that hits a drain in a building eventually makes its way back to the treatment plant and then is cleaned up and reintroduced into the water supply. Correct. So when we find this cooling coil condensate recovery or this dewatering water, the shallow groundwater, which is being lost into a storm sewer system, then we are able to use that water a few times, and then that becomes an additional source of supply to the water utility, so then further clean up and then resend back in. And I'm not even considering that impact yet, because that's harder to measure, right? I'm just looking at pure demand versus recovery in terms of the ROI. But the impact in terms of resilience and sustainability is just not at the building. It goes further into the community, because this is a source of water that the cities, the water utilities were not getting, but now they have it, because eventually it'll leave the building through a sanitary sewer and make its way back to the city, get reclaimed, cleaned up, and reintroduced into the water supply.
So one of the things that, you know, we've discovered across the country is sad but true. Cities often have to do water boils. They have to shut down their water systems. They have their own leak issues and in recovery.
6 billion gallons a day in the United States of fresh potable water is lost because of leaky infrastructure.
6 billion.
6 billion. It's on the EPA's website.
Daily.
That's
a lot of water.
That's a lot of water.
I don't care what anybody says. That's a lot of water.
Yeah.
So I agree with you that there is the primary benefits that you've shown here, but there's also secondary benefits. So for instance, when Wichita Falls ran out of water, you know, Reynolds Aluminum, being Alcoa, I mean, second largest employer, basically had to go find a way to get their own water, and by doing it, they, in a sense, like you said, gave their demand back to the city. And I think we're gonna see more of that occur, and hopefully be incentivized to do more of these types of retrofits. All right, so I know we've just got a few more minutes, but let me ask one or two.
Salient points, if you don't mind.
Yeah,
I'd like
please.
So,
Please.
so one of the things that the asset owners and the building operators are worried about is that they are not familiar with this technology, right? So they don't have the ability to understand what the operations and maintenance of these systems are when they go in. Well,
Right.
what we do is we make sure we have that throughput. We're not interested in a one and done. First of all, it matters to us from a mission perspective, because that's what we do. We're in the water business. But secondarily, it's also important to our brand that when we put something out there, the system remains operational. So I want to reassure anybody that listens that we provide the system design, the manufacture, and the installation, but then also, most importantly, the operations of the system. And we have associates across the country that are certified. If the city certifications are required to do, microbiological testing, et cetera, all that kind of stuff, right? So, secondly, I think that, and I'm going to be careful with this example, but recently, a very large tech company makes a comment that they saved 65 billion gallons of water. Okay, well, the fact is, a lot of these large companies out there have the best of intentions, but they do this using carbon offsets, right? So, does it benefit the United States and the real end user? Yes, you may benefit a rainforest somewhere or areas where there's water paucity, and those dollars are certainly valuable. I'm not devaluing that, but they can something that can actually be done with a financial ROI on the ground at the building in a pretty easy manner. And once that ROI is recovered, then it's a continuous OPEX savings over and over, right?
This is where I was going to ask you to go, and that is ChemSearchFE and NCH, the mother company. You put in very strongly and emphasized the company is a resource management.
Yeah.
In its most simplest, you may not need, as an asset owner, to understand the technology. But what I love about this, and what we keep on trying to identify in this whole future-proofing strategy, is it's resource management, it's resource allocation.
Yeah.
And if you do it right, it will come back in payback and pay off in multiple ways. Because the other
there's two scenarios. Number one, there's doing what's right, and it's time. I mean, maybe not in the United States yet, but it is coming. And the water paucity, I want to be clear about this. The water shortages, I'm not making, or we are not making any kind of claim, even though it might be true that the climate has anything to do with it. The fact is that in most developing countries in the United States, in my country of origin, like India, where you have growing economies, nothing in a growing economy works without the availability of water, right? So the more you grow in terms of a community population-wise, then you have to meet, agricultural demand. You have to meet manufacturing demand. You have to make all of these demands, and all of these are water-hungry, industries. If you run a data center, currently data centers require huge amounts of cooling because the equipment is very sensitive. And from a utility, from an energy perspective, having an evaporative cooling system is still the most efficient. Yes, you can put up a bank of air-cooled chillers out there that don't evaporate water, but then the energy costs are going to go significantly up higher as well, right? So water still is the best media, and those are the target markets. If you run a building, if you're a commercial property owner and you have a large asset portfolio, there are several easy ways to recapture water with a good ROI, less than 4 years. Healthcare, education, hospitality, those are areas, multifamily, where I think the asset managers should know that there are opportunities to reclaim water with a financial ROI while
Right.
meeting the demands of doing the right thing.
Well, and look, and wrapping up, I think the other part that you and your team have been very clear about is the OpEx and the CapEx. Right
Well,
up.
no, I mean, look, it's you can only ask customers to do the right thing so many times, and we live in a capitalist society. At the end of the day, the asset owners, the CFOs, the CEOs have responsibility to their stockholders or their ownership to deliver a financial return. So while the optics might look good, you have to make sure that it all ties together. And we've been really focused on that to make sure that the equipment that we provide has the financial ROI. Otherwise, we will not undertake the project unless we're pushed by the client that they need to do it for some ulterior motive. And we're happy to do that as well. But at the end of the day, we want to save water. We want to make sure that we emphasize that we can provide the communities that we work in, work and live in worldwide, a stronger, more resilient source of water by focusing on areas where it's easy to reclaim some water without having an adverse impact on human health.
So I'm sharing your contact information. Hopefully it's okay that folks can, after viewing this, there's a lot more extensive information, data, and again, I'll come back to that y'all have done a lot of performance measurement in these use cases that I think are relevant for folks that want to become more future-proofed and more resilient, reaching out to you and being able to say, look, we can run some numbers on exactly where you are and where you're not. And I think
we wouldn't do it any other way. I mean, if there's an opportunity, and if there is a asset manager, if there's a sustainability VP that wants to do, and they all claim, what I think is lacking right now is that in the reclaimed water business, there are a few players, but they're very small companies. And nothing wrong against that. That's how America was built. But they just don't have the ability to keep those systems operational and then have the ability to do the design, to do all of that kind of stuff ahead of time, the project management of it. To be able to do that, we feel like we're better suited to that. I guess that's the best way we can put it.
Well,
but we would
politely, you may not be 104 years old, but the company is. It doesn't look like it's going away anytime soon.
No, sir. Fortunately, we're strong. We do operate in 55 countries worldwide. And look, we work on some, like for example, we've been tasked, or the city of Las Vegas has asked us to work with a few of their high-end users to find a way to recapture. There's a very large casino in Las Vegas in the middle of the strip that has 50 million gallons of dewatering a year that is being thrown down a storm sewer. 50 million gallons. So we are undertaking a project with them, and we take on the project in its entirety, from scoping and design to working with the mechanical contractor to get it installed, commissioning, making sure that it's operating effectively, and then most importantly, providing the after-sales service and maintenance to continue to fulfill their promise. And then lastly, the most important thing are the data points, right? So if you do something like this, you need to know what you've done. So our systems are tied into building automation that allows the ownership to actually look at hard data points and go, wait, I actually saved 7 million gallons of water this year, or I saved 5 million gallons of water this year. That's hard data. That's indisputable, right? It's because it's measured using flow meters.
Well, and that goes to the OpEx, and the OpEx is in looking at this performance and being able to measure it daily, monthly, yearly, also supports the incentives, the entitlements that state, local jurisdictions, water systems.
There are a lot. The city of Las Vegas is prepared to incentivize its large users. Because at the end of the day, what the city is looking for is, wait, I don't have this water right now. Send it to me. Figure out a way to get a hold of it, use it. It's your water, but then send it to me so I can send it back within the community, right? So they're looking further downstream 10, 12 years from now, as the city continues to grow, how are they going to meet that water demand, So, I mean, it's in my opinion, the little work I've done, we're beginning to start with them. They are a really forward-thinking water utility, and they're open to innovation and ideas. And it's fun to see that.
Listen, I know I've taken a lot of your time, but hopefully those who are listening in will get a chance to talk with Rahul. Because again, I always learn something every time we talk. And what I like about our conversations, you know what your technology and your solution will do, but I appreciate that you really get to the economics and the operational side of this. And you're able to say pretty clearly that this is how it's going to work, this is how it's going to benefit, but most importantly, this is what it's going to look like on your bottom line. So again, thank you. We will share this with folks across the country. And I encourage those who review all of this, call him, email him. He's very accessible and very enthusiastic about